So this is the first class of Vedant. So Vedant, a quick information for you is, in the class, you don't have to worry about taking notes or memorizing anything. Only thing I expect from each and every child is, just pay attention to the concept that you're learning and then deal with some problems along with me. If you have any doubt, don't hesitate to ask. Okay? And whatever we will do, that is getting recorded and you'll have a video of the class as well, which you can watch later to make your own notes. Okay? So you guys are not getting recorded, it's only me and the board. So don't worry about it. So I had something very interesting that I wanted to teach you guys. And it's going to be a number magic that I want you guys to play with. Does everybody know what is repeating decimals? Everybody?
Yeah.
100%? Somebody is trying to raise hand. Who's that? Abby. So my question to you is, everybody knows what is repeating decimal. If I say, find out 2/6, or let's keep it simple. 1/3. Can you guys convert into decimal? Everybody can do it with ease, without any problem. And for some of you who have not seen this boring stuff from me before, which I call as chicken and egg, I will just show that to you guys one real quick in 30 seconds or maybe 1 minute. Here 1/3, it's simple as dividing 1 by 3. I'm trying to divide 1 by 3. 1 is a smaller number, I cannot. That is when I use a theory called chicken and egg. Meaning, decimal is the chicken that lays 1 egg at a time. That's how I'm relating it, okay? Decimal is the chicken that lays 1 egg at a time. Meaning, when I'm in a scenario where I divide a small number by a big number, this decimal is the chicken that lays 1 egg at a time. Now my situation got better. I can go to 3 3s are 9. 1 remaining. But since I have already taken help from the chicken that lays 1 egg at a time, it will keep going. 1 egg at a time. 3 3s are 9. 1 remaining. Decimal. The chicken lays 1 more egg. 3 3s are 9. 1. Chicken lays 1 more egg. 3 3s are 9. 1. Chicken lays 1 more egg. 3 3s are 9. And goes on. Yeah? And I did that on purpose because, see, this chicken has a very unique property. It doesn't get tired of laying eggs. Only condition is it lays only 1 egg at a time. And again, however stupid it sounds, only thing is, if you are using a decimal, it drops 1 0 at every stage. That's how you can relate it, if you don't like the chicken egg story, okay? So this part is fine, and we don't need to worry about it. So, Ipsa, you have not heard this chicken egg story from me before, right? Okay, so you guys can relate to it. Vedant was a surprise chicken egg story. Okay, let's not worry about that part. So here, what we saw was, when I'm trying to divide 1 by 3, I keep getting this, and there's no end to it. Because my chicken doesn't get tired and doesn't get over. So this is the scenario which is called repeating decimal. Meaning after the decimal, I'm getting 3, 3, 3, 3, 3, 3 so many times that my marker will run out of ink if I keep writing the number of 3s that I'm going to get. So instead of writing 1/3 as 0.333333, I'm saying no, don't worry about it. I will use this roof on the top of this number, which is a sign of recurrence. And this is called the scenario of repeating decimal. Everybody with me so far? So you had a fraction, you converted that to this thing. Okay. Now let me. So you guys know how to convert a fraction to decimal, and if it's a repeating decimal scenario, that will be the case. Let's say if I am trying to divide 1 over 8. Same thing. Put 1 here, 8 here. Oh, I cannot divide. Chicken comes to my rescue. 8 1 ja 8. 2 remaining. Chicken lays 1 more egg. 8 2 ja 16. 4 remaining. Chicken lays 1 more egg. 8 5 ja 40. Done. 0.125 done. I'm not going beyond this. So this is not a repeating decimal scenario. Correct? So I was just showing this to you guys that what is a repeating decimal versus non-repeating decimal scenario. Everybody clear so far, right? Sandrine, Celine, Vedant, Noah, not Noah, Milana, Advik, Arav. Okay, Myra, are you here, everybody, right? Now, let me give you guys a nightmare. So you had a fraction, you could convert that to a decimal, repeating decimal, whatever it was. Now I'm saying, I'm giving you a decimal, let's say 0.12. Well, let me start with the easy one, okay? Let's say 0.6666, or this is the repeating decimal scenario, okay? I'm asking you guys to convert this to a fraction. Do it. How will you do it? Yes, Arav.
The answer is 2/3.
I don't need any magical answer. How will you do it? There's some interesting concept behind it. So, okay, 0.66, you are very happy saying 2/3, right? Okay. Okay, done with it. Convert this to fraction. I will not give an easy way to anybody because I am wanting you guys to learn a concept behind this. Sanvi, Urvi, Saurya, is everybody trying? And guys, keep your video on. I want you guys to keep your video on unless your video is not at all working. Thank you, Dikshita. Yes, Alihan.
I got 39/50th.
39/50th?
Yeah.
Okay, I'll come to you. Let's see. How about everybody else? Is anybody in the class doesn't know how to do it? Or you guys are still working on it? Milana, how about you, beta? Yes, Arya.
It's 0.7 repeating over it's like as a fraction, right?
Yeah.
I got 7/9.
You got 7/9. Okay. Vasundhara, what did you get? Vasundhara, I cannot hear you. Yep. 7/9. Urvi.
7/9.
Okay. Silence lane.
7/9.
Sanvi.
I got 7/10.
7/10. Okay. Itza.
I got 7/9.
Dikshita.
I got 7/19.
Saurya. I'm sorry, bro?
I also got 7/9.
Okay. Rian.
I got 7/9.
Okay. Sorry.
I got 7/9.
Okay, now I will just randomly pick one of you. And somebody whose voice I can hear clearly. So, Saurya, can you explain a bit of how did you get 7/9? What was your technique for finding it out?
So what I did was, well, I'm not really sure Because like I forgot how to convert decimal to fraction, but I kind of understand.
Okay. 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 No, Rians, how about you, sir? Do you want to tell me how did you get that?
I also did it as educational gifts.
Okay. Ipsa?
Okay, so I have 7% remaining because I noticed that 7/10 what is 0.7%. So it's a little bit more than that, so I thought it would be 7/9.
Okay. Vasundhara, anybody who had some method to the madness? Vedant, how about you, brother?
I didn't know how to do it.
Okay. How about Arihan?
I didn't really get 7/9. I got
39 over 50, right?
Yeah.
Okay. Now, Aryahi.
What I did was I did like I wrote down x equals 7 like 47 and what I did multiply it by x so that it would be like 10x equals 7.738 and then I did 10x minus x.
That was interesting. That was very interesting. Yes, Rishika.
Since the 0.7 is 7 for creating, and then I did 77 over 99 because 77 over 100 is going to be a fraction, and if you do 77 over 99, it's going to be a fraction. And then they both come to 11. That's how I got 7 over 9.
Okay. Now I will. So I heard everybody's point of view. You guys made very intelligent attempts. Some of you found the right way to do it. But I like the way Adiyahi described it. Because that is the actual method for doing it. Now let's go back to the history a little bit. Meaning, if you guys remember, if you have, Myra, you are with me? Riyaz, Samrita, everybody with me, right? Would we? Okay. So nobody is with me in the classroom. I am alone in the classroom, by the way. But when I say with me, is it mentally with me? So here, if you guys remember, if I have, let's say, 1.25, a decimal, I have to convert to a fraction. I have a very easy method. What we can do is, if I have a decimal, I will just write the number without caring about the decimal. I just wrote 125. But that is not correct. 1.25 is not same as 125. So there is something to be fixed. And what I do is, for the decimal, there is only one decimal always. So I will write a 1. 1 for the decimal. And then after the decimal, on the right hand side, I will count the number of digits. 1 digit, 2 digits. 1 digit, 2 digits. 2 digits, 2 zeros. Done. This is how we convert any decimal to a fraction. If somebody says 0.707259, convert this to a decimal, to a fraction, I will not even have a single wrinkle on my face. I mean, though I have made you to age, but not because of this problem. What we'll do is, we'll just write down the number 0.07259. I note down the number. Now, I have one decimal, I will write a 1. And then I count how many digits I have after the decimal. 1, 2, 3, 4, 5. 5 digits, 5 zeros. Done. Any number having 0 in the beginning doesn't make any difference. This is what my fraction would be. Everybody knows about it, right? This part is okay? Now, I'm saying this part is okay. But what happens to this guy? If I'm talking about 0.7777 and this is a recurring sign, then how do I do it? I cannot say 0.07 as in 0.7 I mean, forget about this one. Sorry, I put this one, and I will say, okay, 0, 7. I will write 1 for the decimal, and 1 digit after this one. No, this is not 7 over 10. This becomes 0.7. This is not right. I cannot change 0.7777 to 0.7. Correct? This is not the way. Here, the method that Ariyahi showed was this. This is what Ariyahi was saying. So if I have this, I can write, let's say this is equal to x. So here my x is equal to 0.7. Let's add 2, 3 sevens and then put a recurring sign. Okay. Or so basically this is this. My x is equal to 0.77777. So this is how we have written it. We can also write this as, if x is equal to this, if I multiply x by 10, what will happen? I am multiplying this by this, yeah? Or I can say 10 into, let's have one more 7, okay? 0.7 and then a 7, okay? I just use one more 7. So that when I multiply it by this guy, I have a number to multiply. So when I multiply this by 10, my decimal shifts by a place. So it became 7.7 recurring. Is it sounding okay so far? Now, so I got 10x equal to 7.7 recurring. My x was equal to this. Now how about this? I am writing the value of x and writing the value of 10x together. I am trying to subtract this guy. Why I am subtracting? Because this guy has a recurrence after the first decimal. This guy also has a recurrence after the first decimal. So it will help me get rid of this recurrence sign. So 10x minus x will give me a 9x equals 7.7 recurrence minus 0.7 recurrence. This will be equal to 7. Look at this. 7.7 recurrence minus 0.7 recurrence. Only the decimal part are equal. That will get subtracted, get nullified. We got 7. Is it sounding okay? Not able to digest, right?
Not yet.
Not yet? Okay. Let's start the story from the beginning. And I have multiple flavors of it. I'm sorry. Sorry, better?
I understand it.
Okay, you understood it? Okay. Okay, so let me add one more flavor to it. Let's look at another problem, so that some of you who could not follow it will get another chance. Let's say I am trying to convert 0.12 recurrence, meaning I am talking about a scenario where it's 0.12, like your 6, 7 things, right? 1, 2 is repeating so many times. Yeah? Everybody with me so far? Riyan, Sanvita, Urvi, Lana, everybody? Okay. So, let's give it a name x. Okay? Now, I have to convert this to a perfect fraction. But what I have is 2 digits after the decimal which is repeating or recurring. So, what I need is, I need to convert this to something, not x. Let's say some number, let's say I convert it to 20.12 recurrence, then I can subtract and I will be able to get rid of this one. But for us to be able to get 1, 2 again, I will have to multiply it not by 10, because if I am multiplying by 10, I am just moving by one place and I will have 2, 1, very weird combination. So since I have 2 digits, I will move the decimal by 2 places. To get that, I have to multiply by 100 actually. That is how I get 2. Okay, so basically, whatever story I was telling you guys, The only thing is, I'm not multiplying by 10 always. That is not the silver bullet. You have to figure out what number you want to multiply with. Here, since I have recurrence on 2 digits, I will multiply it by 100 so that I can get past this whole combination. Okay. So now let's look at 100x will be what? 100 into 0.12 recurrence, or 100 into 0.12, and then let's have one recurrence and then the one combination of these 2 digits and then the recurrence. Is it sounding okay? No, not yet. Sanvi is okay. Sorry, Thiru, Sandin, Salim, Sanjita, everybody okay? Ichida okay? Myra, Arihai okay? Ifsa is okay? Alright. So here, since I have 2 digits recurring over and over again, I thought, okay, I have to get past these 2 digits so that I get the next pair. So that's why I multiplied by 100. So I'm looking at this in a simple term. So that means 100 of x will be equal to 100 times this. So I'm just, when I'm multiplying by 100, I'm moving the decimal by 1, 2 places. So this became 12.12 recurrence. So my x is equal to 0.12 recurrence and my 100x is equal to 12.12 recurrence. If I subtract this guy, this became 99x equals 12.12 recurrence minus 0.12 recurrence. It will become 12. So x will be equal to 12 over 99. Does it sound okay? Not really. Not very convinced. Okay. Anybody in the class? Saria, Urvi, anybody in the class who is not clear? Vedant, did this make sense?
Sir,
Yep.
can you repeat it, sir?
Yes, 100%. So for this one, we were trying to find out, this is a recurring decimal scenario, okay? Meaning, yes, Milana?
I didn't really get how we got the 99.
Okay, so let's look at it. We are trying to convert this decimal into a fraction. And this is a recurring decimal scenario, meaning whatever be the case, I am getting 0.12, 12, 12, 12, 12, 12, and this guy is not ending at all. Okay. So when 12 is repeating, we put a recurrence sign on the top of that. So basically, I am trying to convert 0.12 recurrence into a fraction. So my basic technique of converting a decimal to fraction doesn't work. Okay. This is a repeating decimal, that's what we call it. So, how did we do? We said, okay, fine, let's say this has a value of x. Now, this repeating decimal, this is kind of little troublesome. It's not easy to deal with them. We want to get rid of that. But our reading is what? I have 2 numbers which are repeating over and over again after the decimal. So, if I multiply this by 100, see these are the 2 numbers, 1, 2, 1, 2 repeating. If I multiply this whole thing by 100, what will happen is my decimal will shift by 2 places. So this will become 12.12121212. Okay? So that is exactly what we did. Since I have 2 digits repeating, I multiply that by 100 so that this 1212 gets moved by 2 places. So by multiplying by 100, it became 12.12 because when you multiply by 10, your digit this decimal moves by 1 place. When you multiply by 100, 1 more place. Multiply by 1000, 1 more place. Multiply by 10,000, 1 more place. That's how it is, right? As many zeros, as many places it moves. Correct? Sami, does it make sense, beta?
Yes, sir.
Okay. So basically, we have to just make a decent judgment that what number we want to multiply with to be able to get rid of this repeating decimal sign or recurrent sign. So when you multiply by 100, this became 12.12. 1, 2, 1, 2, 1, 2, 1, 2. That dance continues. So basically now 100x gave you this much. Your original x was this much. Now when you subtract from this 100x to x, when you subtract x from this, you will see that the recurring decimal part can be eliminated. And this became 12. 100x, 100 apples minus 1 apple will be 99 apple only. That is how we got 99. So 99 apples equals 12. 1 apple equals 12 over 99. The butterfly. Everybody clear? Sammy, clear this time? So now I'm not going to let you guys go. I'm certainly not going to let you guys go. It's not only the teacher whose hand gets dirty. I want my kids' hands to get dirty as well. Convert 0.72 into a fraction. So I'm giving you guys two problems. Convert 0.72 into a fraction. Again, this is a repeating 72. And convert your favorite number into a fraction. Okay? So when you see this favorite number, this is 6.777777. This is not 6767, okay? Now enjoy this, and once you are done, tell me what is the value of the fraction for this one, what is the equivalent of in fraction for this one, and equivalent of fraction for this one. Okay? Enjoy your favorite numbers. I'm here staring at you guys. Vedant, Swari, Thiru, Urvi, Saurya, everybody. I did this on purpose. I wanted you guys to see the fun that math brings along. Okay guys, stop playing with emojis. Get your pens into action. Pens or pencils, whatever you are using. Ajik, Arav, Nihan. Yes, Sanvita.
For 0.72 repeating, I got the fraction of 8 over 11 after simplifying it.
Okay.
And then for 6.7 repeating, I got 61 over 9, but as a mixed number, it's 6 and 7 ninths.
One more time. This one you got as?
8 over
8
11.
over 11. Okay. How about this guy?
As a mixed number, I got 6 and 7 ninths.
Like this?
Yeah.
So you don't have to worry about converting into improper fraction. Into mixed number. You can give me improper fraction also. This is translating to 6 times 54 plus 7, 61 over 9. That is also fine. Yeah. Yes, Vasundhara, what did you get? But come a little closer to the mic. I can barely hear you.
For the first one, I got
13
13 over 18.
over 18. Okay.
6 over 9.
6 over 9. This is 6 over 9. Okay. Let's see. So let me not write down the numbers, because if I keep writing down numbers, you guys will get biased by that, and also it will lead to some confusion. Okay. Yes, Urvi, what did you get? 61 over 9. Okay. So I'm anyways not writing it. Yes, Urvi, what did you get, Beta?
For the first one, I got 8 over 11.
Okay.
And then the second one, I got 61 over 9.
Okay. Dikshita? Okay. Sandy and Celine.
For the first one, I got 8 over 11, and for the second one, I got 61 over 9.
And who is that I? Both? Both got the same answer, Vita?
Yes.
Okay. So, my laptop is about to die. That would mean if it dies, I will switch to my phone and do whatever we did in the last class. Or okay, Milana, what do you get, Vita?
For the first one, I got 18 over 25, and on the second one, I'm a bit confused.
Okay. Arihan?
For the first one, I got 8 11, and for the second one, I got 61 over 9.
Okay. How about Ariyahi, Myra, Saudia? You?
I got 8 over 11 on the first one, and then I'm still working on the second one.
Okay. How about Kiru?
I got 8 over 11 for the first one, and I got 6 and 7 over 9 for the second one.
6, 7 or 9, that is 61 over 9, that's what you're saying?
Guys, so 6 and 7 over 9.
Okay, so that is 9, 6 are 54 plus 7, 61 over 9, yeah, okay. How about Adik and Araf? Yes, Ariyahi, what did you get?
For the point 1 repeating, I got 1 over 9, and then
This one you got 1 over 9?
what?
This one you got how much? 0.7 to repeating?
The point 1 repeating.
Okay,
And then for the point 7 to repeating, I got 8 over 11.
okay. Oh, this is 8 over 11, this one is?
I didn't do that one yet.
Okay. How about Myra?
For solving.
Still solving. How about Abhi? Abhi, Suhina, Tasvik, everybody is quiet. Vedant, how about you, beta? Yes, Abhi, what did you get?
For the first one, I got 72 over 72 hundredths.
Okay.
And for the second one, I got 67 and 7 over 10.
Okay.
Oh.
Yes, okay, that is quite a big number. Let's see. Abhi, what do you get? The second one? Okay. Sandrine, Celine, what do you think, beta? Nothing?
Oh, I already solved it.
Yeah.
First one, I got 8 over 11, and the second one, I got 60.
1 over 9. Okay. Yeah, no, so you said I got, so I was thinking that okay.
I mean,
Both we got. Yep. Arihan, same thing for you?
no.
Okay.
I didn't change my second answer after realizing something.
Uh-huh.
I got 670 over 99.
Wonderful. It's getting interesting. Sorry, what did you get?
I got 6 and then 5 over 9.
Okay. Now I have heard enough answers from you guys. Some of you are still working on it. So Hina, I have not heard her answer. Sorry, I have not shared his answer. Neither has Sammy shared. And Ashrita joined. I don't know when
I'm
we
still
joined.
solving, sir.
Still solving. Okay, Nihan. Saudia.
I got my first answer as 8 over 11, and I got my second answer as 67 over 9.
Okay. So now it's my turn. So Ashrita, I'm not sure if you joined me when I was explaining this, but it's okay. Now let me do this problem. First one, we are trying to solve 0.72 repeating, which is, let's give it a name, 0.72 equal repeating as x. So this is as good as x equals 0.7272. Meaning 72 is repeating, so I'm just taking one pair of 72 out and then putting the repeating thing. Arihan, hold your horses now. Now you will just verify your answer against mine. So here x equals 0.72, 72 repeating. Meaning if I multiply this x by 100, I will get 72.72 repeating. So let's say how much is 100x, and that will be equal to 100 into 0.7272 repeating. Oops. So let me join here.
His laptop died. He's gonna join back on his phone.
I've already joined. Can you guys hear me okay?
Yes, sir. Yeah.
Can you guys see the board also okay?
No, it's too loud in the background. Go to the background and disable.
Oh man, this is, I thought you guys taught me the trick once and that is applicable for the good, forever. Go to background. Video, don't show the video. Go to background settings. Where do I set the background? Is my background blurred still?
Yeah.
Okay.
Actually, just pick the three dots and click in backgrounds and effects.
Okay, yeah. Click the background. Where's the background?
You have to, I think it's effect, the bottom one.
Okay. It's settings, studio sound, video.
So, did you click the three dots?
I did.
Okay, so after you click the three dots, there's gonna be like, I think 7, or 8. There should be like 8 categories in the first.
Inside tools, yeah. Tools.
And then did you click backgrounds and effects?
No. Here. Settings.
No, not settings. Go back to the three dots and click background and effects. It should be an option.
I don't see it. In call messages.
Maybe try screen sharing your screen so we can see it as well.
Okay.
Okay, so do you see those three dots? Okay, wait. So press hide right there. Yeah. So do you see those three dots under the the thumbs down thing?
Yeah. I clicked that one.
Alright, backgrounds and effects. Yeah, that one.
This one?
Yes. And then there should be.
I don't see it.
No, you have to go click the blue square and then remove all.
You have to click the blue square.
Yeah, but he doesn't have the effects applied right now. I feel like this is the normal screen. Okay, now he does. No, take it out. Take it out.
Which one?
Does your phone like automatically? Does it automatically have like the setting or like blurs everything in the background? So, like,
One second. I
I feel like
remember.
it's normal right now. Yeah, I think it may be because some phones they have like a setting where they like put the focus on your face more.
Yeah, that's what I'm trying to figure out. Tools. Okay. Man, this is not right. So, Maya, can you bring the charger while I'm trying to fix this guy here? Okay. Okay. Found it out. Yeah, I found it. Is it okay now?
Yes, yeah.
Okay. All right. Can you guys see the screen? Okay. Board okay?
Yeah. Yes.
Oh, okay.
Yeah.
All right. So here, what I was saying was, we had x equals 0.72. I mean 0.72 recurring is what we were trying to convert. So what we did was 0.72, 72, 72, 72, that's what is happening. So I just took one pair of it out and then 72 repeating. So if now with this guy, if I multiply this by 100, I will have 72 repeating like the original value. So that's why we have multiplied by 100 and we got 100x equals 100 times this, which will be same as 100 will move this decimal by 2 places, 1, 2. So this will become 72.72. So 100x equals this. Now x equals 0.72 repeating. Now subtract. This became 99x equals 72 repeating goes away. It became 72. So x will be equal to 72 divided by 99. And that will be 72 is nothing but 9 times 8. And 99 is 9 times 11. So 9 and 9 tic-tac-toe. 8 over 11 is what the first answer would be. Yeah?
Yes, sir.
Now, second one. Everybody clear, right? Your favorite number that you have as repeating. 6.7 repeating. Atik and Arab, are you guys with me so far? I have not heard any response. I have not heard any question. Who's playing the timer? Please don't do that. 6.7 repeating. Okay. So x is equal to 6.7 repeating. So what it means to us, always look at breaking it down. So 6.7 repeating meaning what? 6.77777 so many times. That's why it became repeating. Okay. So I can as well write this as 6.7 and then repeating on the next 7. Okay. So in that case, if I multiply this number by 10, I will have a 7 repeating like what I have in the original number. So let's multiply it by 10. So 10 of x will be 10 of 6.7 repeating. And when I am multiplying this whole thing by 10, I am just moving this decimal by one place. So it became 67.7 repeating. So 10x is nothing but 67.7 repeating and x is 6.7 repeating. When you subtract this, this became 9x equals 67.7 repeating and 6.7 repeating. 7 repeating is gone. 67 minus 6 is 61. So x will be equal to 61 over 9. Now it's time for everybody to check how it is different from your number if it was the case. Most of you gave me 61 over 9, but some of you gave me other answers as well. I think Vedant, Arihan, yes Nihan.
I put everything the same, but for x, I put x is equals to 0.67 on accident instead of 6.7.
Okay. Okay. So, I mean, I'm just trying to make sure that I'm not teaching you guys something which gets you more confused. Yes, Arihan.
So, in the beginning, I did do 61 over 9, but then I changed it thinking that 6 and 7 were repeating.
No. So,
Yeah.
only 7 after the decimal was repeating. So, that was the reason. Okay.
Yeah.
Now, Suhina, did that make sense to you, beta?
Yes, sir.
Sami,
Yes, sir.
Rians.
Yes, sir.
Okay. Ipsa clear. Saurya clear. Who is not clear? Okay. Dikshita clear?
Yes, sir.
Okay. Now I will just deal with one more problem And that should bring us to the end of the class. How much time do we have? I cannot see the time.
13 minutes.
30 minutes. That is good enough. So, I have a number 12.167. Oopsie daisy. I cannot deal with this combination too much. I just had one escape. 164,329 repeating. Okay. 12.164 and then 329 repeating. So if you want to understand this in simple terms, actually my number is this 12.164, 329, 329, 329. This is what is happening. So that's why instead of writing this so many times and wasting my precious ink, I put this as reckoning decimal. Now I want you guys to convert this to a fraction. And this time I would want to get answer from everybody, including Advik and Arav. And you guys have exactly 5 to 6 minutes for solving it, okay? Don't take much time because otherwise. Yes, please. Go ahead. Yes, Abhi.
Can you repeat the question?
12.164,329 repeating. So 329 is only repeating. Rest everything remains the same. And this has some little tricky element to it. Again, I'm just wanting you guys to play with math. That's why I'm doing this. Yes, Vedant. You say something? How to solve this? I will teach you, but I'm just wanting you guys to be a little creative, okay?
I don't know how to solve this one. So it's a little challenge.
Okay. I'll probably give only 2-3 minutes. This has some additional concepts behind, which I want you guys to learn. So let's give a couple of minutes to just hear what is that you guys tried from your side. Yes, sir. Yes, Sanita.
Oh, never mind. I'm rechecking.
Okay. Yes, Abhi. What did you get?
I'm not sure, but I think it's 108 over 9.
108 over 9?
Yeah.
Okay. 108 over 9. But think about it. 108 over 9. Yes, beta. Just 1 second. 108 over 9. 12 9s are 108, right? So that will give you exact 12. My value is different from that.
Oh, never mind.
Yeah. Yes, yes, Sami, tell me beta.
So all three numbers repeat, right?
Only the last 3. Yeah.
Only the last three, 3 to 9 repeat, right?
Mm-hmm.
Okay. Okay, thank you.
Mm-hmm. Yes, Sanita.
Like, I'm not sure if this is right, but I got 32833 over 199,800.
Okay. Alright. So I don't want you guys to deal with this so much. there's a concept behind this that I wanted you guys to learn. Yes, Sunny.
So I'm still a little confused on how to do it.
Yeah, so that's what. So here, now look at this. When we were solving for situation like this, situation like this, we said, okay, whatever we have after the decimal, we'll look at how many digits, we'll multiply by something, so that after decimal I have the same points. In this case, what is happening is, this repeating decimal is coming after 3 decimal places. And that is what makes it complicated. What you would want to do is, let's say this is x. First, let's get to a point where the repeating decimal is only after the decimal. Meaning, if I multiply this x by 1, 2, 3 zeros, meaning 1000, then I will have 12164.329 repeating. Now this is something which looks more familiar. Yeah? Does it sound okay? Yes, Arihan. Yes, Nihan.
I finished.
You finished? What did you get? So anyways, now,
I got 12,164.165 over 999.
okay, so don't worry about it. We'll just verify this answer with whatever I'm doing. If I'm making a mistake, just let me know, okay? So we have to convert this to a fraction, okay? So 0.19 will not work. Whatever we had, what we are trying to do is, all the repeating decimal that we have to get to a point that after the decimal, we have only the repeating decimal. So that way, it's easier to calculate. So we had this as x, we are multiplying this by 1000 so that the repeating decimal comes right after, this repeating decimal scenario occurs where the repeating thing is right after the decimal, okay. So now this is the case, 1000x equal to this. Now, since we are trying to get rid of this, meaning my number is this, so 1000x is equal to 12164.329, and that is what the repeating scenario is. So now 1000x is this. So if I multiply by another 1000, then I'll get a, so 1000x is this, so another 1000 will be equal to 12164.329.329. I know I picked up a complicated looking problem, but that's okay. It's the same approach. So you had a number, you're trying to make sure that your repeating decimal thing, the repeating thing starts right after decimal. So that is how you got to that point. Now you're treating this like a normal scenario. That okay, fine. I have to knock out the repeating decimal to convert this to a fraction. So whatever I have, if I multiply that by 1000, then I'll have the repeating decimal. So 1000 to 1000, this is 1 million. So 10 to the power 6. X is equal to 12164.329 repeating decimal, and 10 to 1000x is equal to this one repeating decimal, 12164.329. Now you do the same thing. So you are subtracting 1000 from a million, so it will become 999,999. X will be equal to subtraction of this one, so these two will be gone, and this becomes 9 minus 5 is 4 is 5, 2 minus 12 minus 9 is 6, 12 minus 6 is 6, 2 minus 1 is 1, 4 minus 2 is 2, 6 minus 1 is 5, 1, 2, 1. So 1, 2, 1, 5, 2, 1, 6, 5. 1, 2, 1, 5, 2, 1, 6, 5. So x will be equal to 1, 2, 1, 5, 2, 1, 6, 5 divided by 99999. and I'm sure everybody got tired of this. But the idea was not to get you guys tired. What we are trying to understand here is you can have a recurrence thing right after the decimal or after a few places after the decimal. What you have to do is do your magic to get to a point that repeating decimal is right after the decimal. I mean this repeating pattern, the recurrence is right after the decimal. And once you get to that, then you have the same old technique that you can use, that you are using for last two problems. Does it make sense, or got everybody utterly confused and it's giving you a chilling effect due to winter? Yes, Arihan.
I used a different method, but I got the same answer.
Okay. And what is that method?
So basically, I just got that 329, and I put that I did 999 times 12.164, and then plus 329, and then divided by 999, and I got the same answer.
Yeah, I mean, see, there are other creative ways also. See, ultimately the problem is because of this guy only. Find this into the fraction or in the form of in the form of fraction, and then convert this thing to a fraction, add these two. That's it. That could be another way of doing it. Yeah. So instead of dealing with this kind of a big number, you can convert this 329 repeating, dot 329 repeating as a fraction. Convert that part, and then you have 12.164. So this will convert to a fraction, right? 12.164 will convert to a fraction like 12164 divided by 11230 zeros. This is a fraction, and let's say this one converted into a fraction. Let's say something. 329. Okay, whatever it is, by 500, let's say. You can add these two fractions and you're done. Yeah? So, I mean, 1.52 is nothing but 1.5 plus 0.02, correct? Yeah, that is one mistake I made. So when I'm relating it to this one, you have to be careful. This is not 0.329. This is 0.00329. So make sure that the place value thing you are not ignoring. Otherwise this might get a little tricky. But yeah, any option is not complicated. My only thing for you all to know is, if somebody has to drop, can drop off. We are almost done with the class. I'll just take a minute and then let everybody go. So a summary of this was, so far we knew how to convert a decimal to a fraction, fraction to a decimal. And when you are converting fraction to a decimal, there could be many times when you'll come across repeating decimal scenario. And you know what a repeating decimal is. But if you are given a repeating decimal and if you have to convert that to a fraction, this is the approach. This is where you have to be a little creative and solve for it. The kind of problem that I was showing, be assured that this kind of problem is not coming for you guys till 11th grade. So there is no need to worry. As long as you are clear about the concept and approach, that should work. Yeah. So after the class, watch the video of the class, make your own notes, and try solving few problems. Randomly pick up. See, all these problems are not coming from a notebook, right? I mean, I just picked up a concept and I'm kind of explaining that to you guys. So randomly think of any number, try doing it, and see if you are able to do it or if you are getting stuck. And wish you all best of luck. More than you guys, I'm going to wish myself best of luck for the test tomorrow. Let's see if whatever we have learned in the previous classes, how much of that is retaining with you guys. And based on that, we will plan for catching up on those concepts in the future classes. Okay. So tomorrow the class is from 11:15 to 12:45. So it's going to be almost like 2-hour class. First 15 minutes for logistics, when I will send you guys the, yes beta, I want you to take the test to see what are the things that we have done in the class which you have not come across, which you already know, versus something that could be new for you. Okay? Alright, with that being said, I'll let you guys go. See you guys tomorrow at 11 o'clock.
Thank you.
Alright, bye bye.